Assalamu alaikum, my dear students. I hope you are all okay. You are doing well, and I request you all stay at home and stay safe. So, let me remind you about our learning outcomes which we have completed till now. If you remember, first learning outcome was introduction of organic chemistry. Then we have started the hydrocarbons, naming of hydrocarbons, saturated hydrocarbons, unsaturated hydrocarbons, aromatic hydrocarbons, bicyclo compounds, phylocompounds, and their naming. And after this, we have started types of organic reactions. So if you remember types of organic reactions, types of organic reactions. So generally we were saying that there are four types of reactions. Number one, addition reaction. Number two, substitution reaction. Number three, elimination reaction. And number four, oxidation reduction reaction. We are saying it also redox reaction. In our previous lectures, we have completed addition reaction and substitution reaction. Let me remind you again. In addition reaction, we were saying we have further four subtypes. Number one, hydrogenation. Number two, halogenation. Number three, hydrohalogenation. Number four, hydration. We did it, and we have done a lot of exercise, lot of examples related to this reaction. Then we have started substitution reaction. In substitution reaction, we were saying we have nucleophilic substitution reaction, SN1, SN2, SN1 for tertiary alkyl halides, SN2 for primary and secondary alkyl halides. So we have done it also. We have given some examples also, some homework also, some practice problems also. Now today I am going to start elimination reaction. So let us go for this reaction. This elimination reaction is basically either there is removal of one atom or group of atoms. Release of an atom or group of atoms from an adjacent carbon atoms. So basically this elimination reaction and addition reaction, they are just like two sides of the same coin. So if we go through a general reaction of elimination reaction, let me tell you one thing. So for example, if I put here bromine, this is hydrogen, this is hydrogen, this is hydrogen, this is hydrogen, this is hydrogen. Now what is happening here, make sure this carbon where there is attached bromine, we are saying it alpha carbon, and this carbon is called a beta carbon. So the carbon which is next to the carbon where bromine is attached is called the beta carbon. So if it is beta carbon, we are saying them beta hydrogens. So these hydrogens are beta hydrogens. So what we are using here, catalyst, alcoholic potassium hydroxide. From this potassium hydroxide we are getting this base OH minus, which is helping us to remove this beta hydrogen, and there is formation of alkene. So in general reaction we have formation, in elimination reaction there is formation of alkenes. So how it is happening? Suppose if you had to remove this bromine, make sure the hydrogen which is anti to bromine, this hydrogen we can remove it. Any this hydrogen or this hydrogen which is opposite to in transposition. So mechanism will be like this. It will go here and this will go here. So this hydrogen will come out as H positive. Okay, this bromine will come out as bromine minus. So what will happen? What will be the result? The result will be, so we have now this bromine is removed, this hydrogen is also, this hydrogen, if you see this one, it is removed here. So we have here hydrogen, here we have hydrogen, here we have hydrogen, here we have hydrogen. This is alkene. So we can say this is ethene. This is a general reaction and this is simple molecule. But if we have complex molecules like tertiary alkyl halides, primary alkyl halides, secondary alkyl halides, then the mechanism becomes complex and we have to use certain rules to get the alkene. So here what is happening, if you see this H positive, if this H positive and OH minus, what is happening, this H positive, this one plus OH minus from the base, it will make water. Now this bromine and this K positive, they can mix also, K positive plus bromine minus, they will make KBr. This is the complete mechanism of a simple reaction, a general reaction. Now let me go, discuss some more examples with mechanism. So if you see, this is formation of alkenes. Like if you remember nucleophilic substitution reaction, we were having SN1 and SN2 reactions. Similarly, in elimination reaction, we have two types, E1 and E2. E1, what is E? Elimination. What is one? Unimolecular. So what is E2? Similarly E, elimination. What is 2? Bimolecular. So generally this E1, it is completed within 2 steps. 2-step reaction. Generally comes in tertiary alkyl halides. This is 1-step reaction. And it is for primary and secondary alkyl halides. So let me start this first E1 elimination reaction. So before starting the mechanism of E1 elimination reaction, we had to go through a rule which is very important for this reaction, that is use of Zetsev's rule. It is also called Sisyphus rule. So before starting any example for this, we must know what is Zetsev's rule or Sisyphus rule. What it's saying, this is saying most stable, most substituted alkenes are most stable products. What does it mean? It means if we have this is butene 2, this is butene 1. This double bond is highly substituted. This is highly substituted. If you see this, it has this carbon, this carbon. How many heterogeneous? 1, 2, 3, 3 plus 3, 6 heterogeneous. 6 is alpha heterogeneous. If you see here, so we can say them, suppose here a heterogen, how many heterogens attached to this double bond 2 carbons? 6 alpha heterogen. If we say this is beta, this is alpha, this is alpha, this is beta. So 6 beta heterogens. But if you see this double bond, it is attached with this carbon, so it has only 2 beta heterogens. Now this rule is saying most substituted alkenes are most stable products. In other words, it is saying more the number of, in another way, it is saying more the number of beta heterogens, more stable is the alkene. So we have two definitions for Z-Series rule. Why I am discussing this rule? Because we cannot complete this reaction without knowing this rule. That is why I first took some time to let you understand. We use the Z-Series rule and C-Series rule. What it is saying? So most substituted alkenes are most stable product. So if I took a simple example, butene 1, butene 2. This double bond is surrounded by 2 carbons here. Here are 6 hydrogen, here 6 hydrogen. If I consider this double bond as alpha carbon, this carbon and this carbon is beta. So we have beta heterogens. How many? 6 beta heterogens. Here we have 2 beta heterogens. So because there is no carbon is attached with the double bond carbon. So in another way, this rule is saying more the number of beta heterogens, more stable is the alkene. So let me go for mechanism for E1 elimination reaction. So there I will use, because we have probability of 2 products, less substituted alkene, more substituted alkene. So we have to use this rule to figure out which product is more stable, which is major product, which is minor product. Let me go through it. So, stepwise mechanism. So if I take this compound, so what is the name of this compound? 2-bromo, 2-methyl butane. This is tertiary alkyl halide. So step number 1, what will happen? This bromine will come out. It will become tertiary carbocation plus bromine minus in presence of alcoholic KOH. Now in the second step, this tertiary carbocation, it will be attacked by OH minus from this, because KOH, it will give K positive plus OH minus. This is the base which is attacking on the carbocation here, positive charge of carbocation. So this OH, so what it is doing, it is trying to remove hydrogen from this beta, from this carbon and this carbon. It means we have two options. It can remove hydrogen, 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 hydrogen. And we have two options. Either it can remove hydrogen from this, or it can remove hydrogen from this. For example, if it will remove hydrogen from this carbon, so what is going to happen? This, so double bond will come here. Okay. Now this is case, this is A. So I will write here A. Now if it will remove hydrogen from this case number 2, then double bond will come here. Okay. Now if you see, as per the Z-Sievers rule, as per Sievers rule, what they are saying the highly substituted alkene is the major product. So if you see here, we have, this is beta hydrogen, more number of hydrogens attached with the double bond. Here only this hydrogen. So if you see, this is the major product. It is near about 70%, and this is the minor product. It is near about 30%. Now if you see, what will be the name of this compound? So 1, 2, 3, 4. So 2-methyl butene 2. What will be name of this compound? 2-methyl butene 1. This is about E1. Now let me give you some examples, some exercises how you can do it. So I wrote here A, this is from B. So first I took hydrogen from this carbon, this is A. Then in second case I remove hydrogen from this carbon. So this is B. That's why I wrote here A, this is B. So this is major product because it is highly substituted, and this is minor product because it is less substituted. Let me give some practice problems now related to E1 reaction. So practice. Give the product. Number 1. Give the product. If you see, what will be the name of this compound? 1, 2, 3. 1, 2, 3, 4, 5, 6, 7. The name will be 3-bromo, 3-ethyl heptane. 3-bromo, 3-ethyl heptane. You can start naming also from here. Numbering 1, 2, 3, 4. Name will be again same. If you see here, so you have to start numbering from here. 1, 2, 3, 4, 5, 6, 7, 8, 9. What will be name? 3-chloro, 3-methyl, no name. You have to give stepwise mechanism for E1 reaction. E1 reaction. So there will be two steps. First step will be carbocation formation. Another step will be removal of hydrogen from the beta carbon, and you will get alkene. There is possibility of two products. One is major product, one is minor product. Similarly, in this case, first step is formation of carbocation, which I show in my previous example. So the first step will be formation of tertiary carbocation. Then there is abstraction of hydrogen from the tertiary carbocation, and there is possibility of two products, A and B. One is highly substituted, one will be less substituted. So as per the Z-Sever's rule, as per the Sisyphus rule, the highly substituted alkene is the major product. So this is about elimination reaction, and it is E1. In the next lecture, inshallah, I will continue E2, and we will try to finish redox reaction also. Thank you.